radius when he says the radius of the cylinder. So I mean the top of it.
So the radius of the cylinder is, yes, it's this part.
Yeah, that's what I'm talking about.
Yeah.
So
Half radius is half of the whole. So this is the diameter, but it's half of it.
this is
Okay. So how about we start now? Yeah.
so 45.
So welcome everyone. Every single one of you. It's good to have you. Today we're going to talk about statistical claims for half of the class, and for the other half we'll discuss. I think it was forgot the name. Yeah, areas and volume. So that should be interesting. First 60 minutes, we did some exercises. I hope that was refreshing enough for you. And now we can start. And now we can talk about area and volume. Now this will be familiar. I mean, I hope this will be familiar to you, because it could be a recap for things you already took in middle school or high school. I'll also try to communicate a certain way I like to view areas and volumes. So at least throughout my academic career, I've never had to memorize a formula that's related to area and volume. And the way I was able to do this is by certain intuitive understanding how this works. And with the following questions, I will try my best to at least communicate that to you, so you don't have to memorize formulas before. But I think even if you memorize them, I think they're also on the SAT formula. But you lose a great amount of time looking for the formulas and all that. So it's not really fruitful if you think about it for a moment to utilize these formulas. So this is one of the questions. I mean, you can of course think about the problem, but I'll just draw. This cylinder. They also use this thing. I mean, zoom in on myself. It's gonna be funny. This is what a cylinder is. And just to cement some two concepts, and if we talk about area and volume, so area is usually two-dimensional, and volume is three-dimensional. So this is a three-dimensional object, has a volume. And if you talk about area, you talk about, for example, the surface of this object or this table or any other object. But why do I have this in my hand now? It's because I would like you to imagine the following. If you would like to find the volume of this thing, we can decompose this thing into two things. The first thing is circle, and the second thing is a line. So I want you to imagine that I have a very nice knife with which I cut very small pieces, cut this all into very, very, very small pieces. And then I arrange them on top of each other, and then I get this shape. If you look at it here, so it's something that looks like this. So this is what I mean when I talk about how I'm able to find volumes and such. So it's like you take this very small circle here, and you have this line, let's say this line, and you're sweeping the circle across the line. And this is what causes this cylindrical shape. Now, if you would like to talk about this whole area that's covered, but I don't want to say area, maybe I'll say volume to be more precise, that's covered. While you sweep your circle across, or it could also go the other way around. You could also take the line. I want you to imagine this, but you need some imagination. You keep doing like this for every single point that is there in the circle. And then it boils down to a simpler task, which is to find the area of the circle here, and to find the length, and always check that the dimensions match. So I think it is not too difficult to see that the circle is a two-dimensional object, and that length is one-dimensional. I think this is very crazy, but if it's not, you can always talk about it. So it's kind of like, and I use quotations because this is very bad. It's not rigorous. It's kind of like if you multiply the two, you get something that's three-dimensional. And by multiply, we mean this nice visual image of, having a circle for each point on this line, or having a line that extends from every single point on this circle. So I really hope that this visual image is clear, because I think it's very nice. That's just a subjective opinion. And I think we can find the area, find the length, and just multiply them by each other. Then we'll be able to find the answer to the question. So this was like a brief interlude on the way I like to see volumes and stuff. But anyway, so now let's start reading the problem itself. So what are the facts? This is the fact. It says that the height is 4 inches longer than the radius. So you take the radius and you add to it 4 inches. Let's just write 4. Okay. So the length is h, right? We said length of the line times the area of the circle. Now the length of the line is h, right? But I can replace it with r plus 4. Okay. Now what is the area here of the circle? Pi r squared. Yeah, sure. No, I'm not trying to correct you or anything. Pi r squared. Okay, the area is still pi r squared. Then you have r plus 4 and pi r squared, and you multiply these two things. So this is how you should intuitively understand. So you don't need to memorize a formula. You don't need to do anything. You take the length of the line, you multiply it by the circle, so that you're able to find the volume, which is a three-dimensional object. And I don't even know what the volume of the area of a cylinder is, or the volume of a cylinder. I don't need. Well, I don't need to memorize it. That's what I'm saying. You know what I mean? It's very nice, because just simplify your problem into simpler parts. So this is the answer: r plus 4 times pi r squared. This will give me pi r cubed plus 4 pi r squared. which is this. So that's really that's really what I wanted to communicate. I mean, I always upload the notes, but if you would like to, it's definitely. Sure. Do I look good?
Yeah, sure.
Okay, thank you. Thank you.
Right. And just not here. Brain, just brain.
You want okay, the photo, the
Yeah.
circle?
No,
the drawings, okay.
The rest.
What do you mean?
Yeah,
This one? Oh, you want this one? There you go. Yeah, of course. Okay. So here's another one.
Just plan 60 plus 20%.
Okay, I'll write what you just said. That's what he said. Okay, I just show what he said.
Or you can also write the length plus 20% multiply width plus 20%.
So times
Who's equal to area.
I'm just writing what you say. Let me actually now draw some stuff. So this is a poster. The area is 360 square inch. So I write inch and I write foot 2 power 2. Let's see. A copy of the poster is made, and if the length and the width of the original poster are each increased by 20%. Okay. So the area is 360 plus 20%. But what do you mean plus 20%? You mean 20% of 360?
Yeah.
So you mean this. Right. So you mean that 360 will increase by 20%. So
Yeah.
this is how it's 20% of 360.
That's
what-
like 20%
yeah.
of what?
Because if you just write, but yeah, if you just write 20% of one doesn't really make sense. But what do you think? Do you think that is the answer? But here's the thing. So what's the value of the original area? By the way, you don't need to know the formula for the area of the rectangle. But if you think about this, if this is the width and this is the length, the reason why we multiply the length by the width is because you take the length, you sweep it all over the width, and you get something that's two-dimensional. I'm also trying to reinforce the idea that we were talking about in the previous problem. I presume you already know how to find the area of the rectangle. I think the bit when
Equals to the length is 2 times the width.
this is not necessarily true.
Then you can say anything. You can say like 2 and 180.
So you would like to take an example.
The length would be 180 and the width 2.
So usually it is not a good idea to
Yeah, because
use
it-
examples, but let's do it. Let's do it. Let's just assume. I mean, it will work. So it will work for one reason. It's because it should work the way it is phrased, it should work for any sort of what's it called? Any sort of example, the way that it's phrased. Let's take a very simple example. You know, I'll take 360 inches and I'll take 1 inch,
Okay, that's correct. So,
right? Then 360 times 1 is 360 inch squared, right?
yeah.
Okay, now can you add 20% to this?
Okay. 20% of the
Well, I know this one is going to be 1.2.
Finish.
This is going to be 372.
No.
472.
Yeah. So,
432, not 72.
Yes.
62.
20%.
What's 20% of 360 is
72%.
72. Yes, yes, yes. Okay. Now, if you multiply this by that, you get a number that's 20% of. So if you multiply this and you get a number, is it the 20% increase in 360? Now I'm just trying to build the non-example here. It's not, but why not?
Because you're adding like.
because I think also 20% should be multiplied by each other.
So you mean that this is 20% and 20%, and the output is just 120%.
Yeah.
Okay, let's make this more precise. So this was just like a counter example. Let me make these ideas very precise. So the original area, let's say area old, was length times width, right? Let's say length old times width old. Okay. Now this was equal to 360 squared inches, right? Now let's look at L nu. What is it equal to, and what is W nu equal to?
452,
No, I'm talking about lengths and widths.
360.
No, that's just the example.
Yeah, but
That's a very specific example of it. But can you?
no, I'm
Can you?
saying 360 plus 20% of 360.
No, I'm not asking about the area. Let me be more
Yeah,
precise.
I'm saying for the length, it's like 360 inches plus 20% of 360.
Yes, that would be true if you're just considering this example. I want to take a general example.
Oh, okay.
But yes, in this case, this will be 100% correct. So L nu would just be 20% extra of the old L. This is what I meant. You see, I'm not using any numbers. That's what I really wanted to do. And the same thing I can do here. Is this okay for Stephanie and Joseph? You guys are there, right?
Yeah.
Okay. Okay, that's good. So, 20% increase. Now remember the old area, it's 20, it's the old length times the old width. Now what is the new area?
Yeah. 360.
It's the new length, right?
Yeah, the same one as I told you. L plus 20%, but like W plus 20%. Or L nu plus W.
So it's the new length times the new width. And now we make a nice substitution. So I replace L nu with 1 plus 20% times L old. And I replace W nu with 1 plus 20% times W old. And here is what I think you were pointing out briefly earlier, which is that it's kind of like the 20% gets multiplied twice.
Yeah.
well, to see this, I would like you to expand this actually. Can you expand the?
LW.
So you would get, here's what you would get. You would get L old plus 20% L old. So that the symbols are supposed to make your life easier. If they're making your lives harder, let me know. We'll try something else. Now let's multiply this out. It's really what I wanted to do. You can try to multiply this out as I arrange my page with more space. But here's what we get. We get L old times W old, right? Plus L old, this is the first thing, this is the second term, times 20% of W old plus 20% of L old times W old plus 20% L old times 20% of W old. Now I might need to prove this, but here's what's happening.
L-old cancel.
So these two terms are exactly the same. Right, so I get 2 times %, times L old times W old. Plus, now here you get 20% squared times L old times W old.
Why it doesn't cancel?
Nothing needs to cancel out. Now all of them have an L old and a W old factor. Maybe I should have even left these ones out. Precisely, this is what I should have done. Here's what I mean. We were here. I'll just expand the brackets that are in the middle. Well, actually, I don't need to expand anything. That's the point. I think I made a mistake by expanding, because that was just complicating the problem. Just look at this, okay? Just look at this. We don't need to expand anything. So this is L old times W old. I'll just change the placing of some of the terms. This will be here, this will be here, and these will be there. Guess what? These two terms are exactly the same, and you're multiplying them by each other, right? Then I can just square this, and it will be 20% increase twice in the original area. You see now what will happen.
Yeah, that's why I immediately included the other function with L plus 160 plus 20% of L multiply the width plus the.
Because here's the thing, we multiplied L, but we increased L by 20%, we increased width W by 20%. Then in in the very end, what we get is a 20% increase twice, which is 20% square increase in the area. So you just compute this value and you get your answer. Now, here's the thing, you don't need to do this in the exam. I just wanted to make a point. The point is, this area has two components, length and width. This length was increased by 20%. This width was increased by 20%. And in the end, to get my area, they get multiplied. So to keep this consistency going, I should also multiply, by this increase by 20% twice.
Wrong way to do this.
So the wrong way to do it is just to multiply 360 by 20%. But what you need to do actually is you need to multiply it by, you need to multiply it by 1 plus 20% twice. So what do I mean by 1 plus 20%? I mean 1.2 or 1.20, because 20% is 20 over 100. This is just
That's فلوس.
this is just math, right?
Is that فلوس? 100.
No. Okay, so I did this once and I get a number. I should do it again. So I get this number, I multiply it again by 20%. So that's the idea of the squaring. If you square something, you multiply by it twice. I'm just dissecting this. So it will be 518.4 inches squared. And let's actually check what happens here. So what if I multiply 432 by 1.2? Amazing, right? So here's the thing. If you didn't really get what was going on in the last, 10 minutes, and you decided, okay, I want to be able to solve this problem fastly, then just choose a length and a width that's appropriate and increase each one by 20% and see what you get. So this is funny, right? Because this is the correct answer, and we got it just by applying it to one example. But the idea persists, and that is you need to multiply the length by 20%, so to increase it, and you need to multiply the width by 20% to increase it. Now, it's not correct to say multiply by 20%, but so there's a bit of an abuse of words here. But what I mean to say is you need to increase it by 20%. So I use these two terms interchangeably. I hope that's not a big issue.
Okay.